Dear students, welcome to next one-shot lecture of industrial engineering. Today we are going to discuss transportation problems. As we have discussed before, the motto of this one-shot series, that in one lecture you get all basics important for this year GATE examination. Of course, especially in industrial engineering, I am covering most of the topics, but I am getting into deep discussions only of few aspects. The aspect that I think that this particular aspect will be important for this year GATE examination. So I am going deep into only that area. Okay. This is our team Drona. As I tell in every class, it is not the work of one teacher, it is a group. So what I am going to discuss in this particular lecture, what are the different methods of finding out the initial basic feasible solution? Then Modi method, it is not Narendra Modi. It is called modified distribution method. It is a way of achieving optimality, Modi, but because Modi is very popular, okay. See, there is another method called stepping stone method, but that is stepping stone we are not going to discuss in the one shot. We will discuss only the Modi method, modified distribution. And we are going to also discuss the degeneracy in transportation. And we will also discuss when we add dummy columns and row in transportation. And this is my profile. I am gold medalist in Aligarh Muslim University. I am M.Tech and PhD from IIT Delhi. Between M.Tech and PhD, 1.5 years I worked for engineering services. And I'm a researcher. And as per Scopus data, I'm top 5 partner researcher in the world. Scopus maintains the researchers' articles over a web page called sciencedirect.com. I think some of you may be knowing. Okay, let us begin our discussion on transportation. So, first we will discuss the different methods of finding out the initial basic feasible solution. I am taking the same problem and trying to find out the initial basic feasible solution. Like in the regular classes, we will get into too much details about each and every aspect so that the syllabus is covered completely, but in one shot, our targets are different, okay? So this is the typical transportation problem. There are 3 plants, plant A, plant B, plant C. And there are 4 stores, 1, 2, 3, 4. Whatever written in the bracket is the transportation cost per unit. Transportation cost per unit. Suppose you want to move material from plant B to store 2, unit cost is 8 rupees. From plant C to store 4, 5 unit. Okay. Now, the capacity of different stores are given to you. Capacity of store 1 is 7. Capacity of store 2 is 12. Store 3 17 and 9. And the capacity for different plants. Plants A capacity is 22. Plant B capacity is 15. Plant C capacity is 8. So capacities are given to you. Now I am finding out initial basic feasible solution by northwest corner method. Before finding the initial basic feasible solution, we have to see that whether the transportation problem is balanced. So how to see the balance? Add these capacities and these capacities. 22 plus 15 plus 8 is 45. Now see the column capacity, 7 plus 12 plus 17 plus 9. It is also 45. Okay, so this indicates that the problem is balanced. Okay, when these two numbers are same, it means the transportation problem is a balanced one. I will start the procedures of initial basic feasible solution only when the transportation problem is balanced. If the transportation problem is not balanced, I will do something else. Okay. Now my first method is a northwest corner method. So if you see the world map, this side it is the east, this side it is the west. North, east, west, north, south. Okay, that's the way we do it. So what you do, you select the northwest corner method. You select the northwest corner method and start allocating as much as you can and keep on moving in the forward direction. Either you move in the row side or column side wherever capacity is available. So select this column. Column capacity is 7. Row capacity is 7. So maximum you can allocate 7. So column is satisfied. So I am discussing the northwest corner method of finding out the initial basic feasible solution. Okay. So column capacity satisfied. It means go to the next column. How much is left out? 22 minus 7 is 15. So I can allocate 15, but the column capacity is 12. So I will allocate only 12. So second column is also exhausted. Second column is also exhausted. So out of 22, how much you have already allocated? 19. How much left out? 3. So out of 22, 19 is already allocated, left out is 3. So 3 you allocate in the column number 3. So the first row is also exhausted. Now from the column, out of 17, 3 are allocated, remaining are 14. So to allocate 14 here. 14 plus 3, 17. This is also exhausted. In the second row, capacity is 15. You have already allocated 14. One left. So 1 you allocate here. Now we don't have any option to allocate 8 here, so this is also exhausted. This is also exhausted. So take the northwest corner, and start allocating the maximum number of allocations. This solution is called initial basic feasible solution by northwest corner method. Similar to simplex, northwest corner method gives you matrix similar to the initial matrix of simplex. This solution is very, very far from the optimum. This solution is very far from optimum. Some of you may be thinking that what I'm eating, it's a lawang. Because I was having fever, so still there is a coughing because I have to record. So I have put one lawang in my mouth so that the coughing doesn't come. Okay, so initial basic feasible solution is very, very far from optimum. So how much is the total transportation cost? Total transportation cost will be see 5 into 7 plus 2 into 12 plus 4 into 3 plus 1 into 14 plus 6 into 1 plus 5 into 18. See, I have already solved because these are some of the examples of my book. So it comes out to be 131. 131. Okay, but as I already told you that northwest corner method gives you solution very far from optimum, and if you compare the simplex, it's a very, very initial table of simplex. It's a very, very initial table of simplex, but it's a solution. It's a solution. Now there is another method by which I can find out the initial basic feasible solution called least cost method. I told you in the last simplex lecture, I told you that simplex is meant for profit maximization. Simplex problems are meant for the profit maximization, and this transportation is for loss minimization or the cost minimization. Loss or cost minimization. You know what is the meaning? To begin the iterations of initial basic feasible solution, my matrix should be a cost matrix or loss matrix. My matrix should be a cost matrix or the loss matrix. But suppose in the transportation problem, suppose in the transportation problem, if the profit is given, in the transportation problem, if the profits are given in the matrix, we have to convert that matrix into a loss matrix. How? How? Select the maximum value in the table, let us say 8, and subtract each and every element from this 8. 8 minus 5 here, 8 minus 2 here, 8 minus 4 here. So select the maximum value of the table and then subtract each and every element of the table from that maximum. You will get a loss matrix. Okay, so that is a way to handle. That is a way to handle profit matrix in transportation. So now the second method is the least cost method. What we do here, select the least cost in the matrix, least cost cell in the matrix, that is 1. Select the least cost cell in the matrix, that is 1. Allocate as much as you can. Row capacity is 15, column capacity is 17, so I can allocate only 15. So row capacities are full. Okay. Go to the next high transportation cost too. Allocate as much as you can. Column capacity is 12, row capacity is 22, so I can allocate only 12. By that way, row capacities will be full. So I keep on jumping on the next higher transportation cost. Next higher is a 3. Column can accommodate 9 and the row can accommodate how much? 10. Because 10 is left now. So 9. This column is also exhausted. Next higher transportation cost is 4, 4 at 2 places. So allocate on any cell. 4. As per row, how much is left out? Only 1 left out. And the column 2 are left out. So I can allocate only 1 because this row will be exhausted. Now since there is only 1 row, you allocate whatever you want. 15, 16, 1 left out, 17, and then 7. Everything is exhausted. Okay. Now for the total transportation cost, 2 into 12, 4 into 1, 3 into 9, 1 into 15, 4 into 7, and 7 into 1. If you do this multiplication and addition, total transportation cost is 105. Total transportation cost is 105. This least cost method gives you matrix better than northwest corner. And it will be somewhere the middle table of simplex. After a few iterations, some middle table of simplex. So this is the second method of finding out the initial basic feasible solution by using least cost method. Okay. Now there is a third method of finding out There is a third method of finding out the initial basic feasible solution, and this method is called Vogel's approximation method, and it is also called penalty corner method. Vogel's approximation method or penalty corner method. In GATE exam, if it is given that initial basic feasible solution, you calculate by Vogel's approximation or penalty corner or northwest corner, then we have to follow that approach. But when nothing is given, please hear very, very carefully. When nothing is given, then for finding out the initial basic feasible solution, which method has to be followed? By default, follow the Vogel's approximation method. In the exam, when nothing is given, that which method you have to follow for finding out the initial basic feasible solution? Blindly follow Vogel's approximation method. Okay? But when it is given that follow the least cost method, then we will follow the method number 2. So GATE problem, we have to read very, very carefully. Don't solve the problem in rush. Okay? This Vogel's approximation method gives you the initial basic feasible solution better than the least cost method, and this matrix will be close to optimum. It may be optimum, but even if it is not optimum table, it is very close to optimum. So how to solve it? We calculate penalties of row and penalties of column. We calculate penalties of row and penalties of column. Penalty is nothing but difference between the two least transportation cost. Penalty is nothing but the difference between two least transportation cost. See, as I told you in the previous 2 industrial lectures, graphical and the simplex, here also I am telling you, because all of you are not live, you may have to see some portion of this lecture again. And if there is any doubt, please direct all the doubts to me through PW. There is a Telegram channel. Below also this, there will be link to join the Telegram channel. Dr. Shreshth Singh or SK Singh, there will be name appearing on my profile. Just direct all the doubts to me. I will take care of all the doubts. Okay. So penalties are difference in the two least transportation costs. So in this row, least transportation cost is 2 and 3. Difference is 1. Row 2, minimum is 1, next higher is 4. So 4 minus 1, 3. That's how we calculate penalties. Row 3, minimum is 4, next higher is 5. So penalty is 1. Calculate the penalties for the column also. Minimum 4, next higher is also 4. 4 4, so penalty is 0. 2, next higher 6, difference is 4. 1 and 3, penalty is 3. 3 and then 5, penalty is 2. So we have calculated the penalties. Now select the maximum penalty. Select the maximum penalty column or row, whatever appears. So maximum penalty appears in the second column. In that column, select the minimum transportation cost cell. Minimum transportation cost cell, and allocate as much as you can. Column capacity is 12, row capacity is 22, so I can allocate 12, and by that way column 2 will be cancelled. Okay. After that allocation, either row or column will be cancelled. After each iteration, calculate the penalties again. So if I am calculating the penalties of row, I will not see the transportation cost of cancelled cells. These cells are cancelled now. So I will not see the transportation cost of the cancelled cells. Calculate the penalties again. So 3 and 4, 1. 1 and 4, 3. 4 and 5, 1. Here 0. No penalty because the column is cancelled. 3 and the 2. Now 3 appears for there are two options, this row and this column. If there is a tie, which row or which column I will choose? The row in which there is a minimum transportation cost. That row or that column I will choose. If I choose this cell having one transportation cost, if I choose this, same cell appears. So you can choose whatever you want to choose. So now the column capacity is 17, row capacity is 15, so I can allocate only 15. This will be cancelled. Calculate the penalties again. Calculate the penalties again. 3 and 4 is 1. No penalty because this row is cancelled. 4 and 5, penalty is 1. Come to columns. Now this is cancelled. So 4 and 5, 1. No penalty. 4 and 3. 3 and 5, 2. So the maximum penalty is here and the minimum transportation cost is 4. Allocate as much as you can. Only 2 is left. 15 is already allocated. 17 is capacity. Only 2 you can allocate. This is also cancelled. Again calculate the penalties. First row 3 and 5, 2. No penalty. 1. 1. No penalty, no penalty. 2. So 2. This is the cell. If I select this row, same cell is appearing. So here 8 is left in the row. Column capacity is 9, so you can allocate 8. So this row also cancel. Now only one row is left out, correct, na? If either only one row and only one column is left out, no need to calculate penalty. Select the minimum transportation cost 4. How much is left out? 7. Here 1. So these are the allocations based on Vogel's approximation method or penalty corner method. Vogel's approximation method or penalty corner method. To calculate the total transportation cost, 2 into 12, 4 into 2, 3 into 8, 1 into 15, 4 into 7, and 5 into 1. So if you say total transportation cost comes out to be 104. 104. See, 1 less than least cost method. 1 less than the least cost method. 1 less than the least cost method. Okay, 1 less than the least cost method. In exam, when no method name is given to you, you have to use the penalty corner method or the Vogel's approximation method to find out the initial basic feasible solution. To find out the initial basic feasible solution, okay? And what I told you, what I told you, that this table will be very close to optimum. Now, how to check whether this solution is an optimum one or not? How to check that whether this solution is an optimum one or not? And the way we check whether solution, who will check? Modi will check. Modi method. MODI, Modi method. Its full form is modified distribution method. Okay, modified distribution method. So let us see the final matrix by Vogel's approximation method. Whatever we have got. If it would have been the live class, it would have been really excellent. All your doubts could have been taken care of. Same problem I'm taking. This is my book only, whatever. Okay, na? Some of you may ask that which book it is. It's my book. Narosa will publish it, and maybe February and you will get it in the industrial book. 5243 4816 4675, and the allocations are 12 to 8, 15, 7, and 1. So these are the allocations. Okay. Now I am discussing what is Modi method. Modified distribution method. You know, recently I made one generic session video, It will be available on our Gate main channel. How to control anger? Because there are a class of people, by hearing the name of somebody they gets angry. So for a student, anger is very, very bad. For anger is bad for everyone, especially a student, because they have to crack exam. So look at that video. It is going to appear on Gate Wallah main channel soon. Okay. So how to find out optimality? Okay, na? So now you allocate any number. First of all, before moving towards optimality, you have to check whether the problem is degenerated or no. M is number of rows. Number of rows, you are 3 here. N is number of number of columns are 4. M plus n minus 1 is equals to 3 plus 4 minus 1 is 6. So m plus n minus 1 is equals to 6. Number of allocations are 1, 2, 3, 4, 5, 6. So number of allocations are equal to m plus n minus 1. Number of allocations are m plus n minus 1. So it means we can move towards optimality. If number of allocations are equal to m plus n1 minus 1, it means the matrix is ready for moving towards optimality. If the number of allocations are less than m plus n minus 1, it means the problem is degenerated. We have to do something. We have to do something to the matrix before I can apply the Modi method. But here there is no issue. There is no such issue. Now you do one thing. You are giving some arbit number. Here you should see carefully, because this is the little important step. Vj is any number given to row. Uj is any number given to column. So you give any number to any row or any column, but this facility is given only once. Choose your lucky number. Allocate anywhere. Let us say you allocate here. But this facility is given only once, because all other numbers will come out automatically. All other numbers will come out automatically. Here there are something called water values. Water value of any cell is ui plus vj minus Cij. We are calculating now here very carefully, very carefully, all of you should hear. It's a very important point for all the competitive examinations. Very important point for all the competitive examination. Water values are ui plus vj minus Cij. Ui's, vj's, Cij is the transportation cost of that particular cell. The cell for which you are calculating the water values, Cij is the transportation cost of that cell. Okay, and the transportation cost of allocations will be 0. Transportation cost of allocations will be 0. So this choosing your number is allowed only once. Is allowed only once. All other numbers will come out automatically. For example, you have given the first row number 0. Now there is an allocation here. So what should be the uj so that the water value is 0 here? It should be 3. This is the water value. 3 plus 0 minus 3 is 0, because the water value for allocations will be 0. Water value for allocations will be 0. So there is another allocation. This is 0. So this must be 4. 0 plus 4 minus 4 is 0. These are 2. So the ui must be 2, because 0 plus 2 minus 2 is again water value 0. So all other ui and vj will come out automatically. So here there is an allocation. Here there is a 4. So this must be minus 3, because 4 plus minus 3 is 1. 1 minus 1 is 0. So water value again 0 here. Everything else will come out automatically. 3. So this allocation must be 2. 3 plus 2, 5. 5 minus 5 is 0. So water value is 0 here. Here is an allocation. 2 is this value. So this also must be 2. So 2 plus 2 is 4. Minus 4 is 0. Understood? So selecting your lucky number is allowed only once. Is allowed only once. All other ui and vj's will come out automatically. And the water values for allocations will be 0. Water value is ui plus vj minus eij. Okay. Okay, is that all right with everyone? Huh? So now if it is a live session, many students would have asked many questions, but here, because it's a recorded one, the way I am finding the optimality, I think this section you should see it again, because more number of times if you see, more fundamentals we will get it, because this particular section is packed with information. Generally in the offline or the live classes, I will take around approximately 5 hours for transportation, but this will take exactly half of the time. Okay. So ui plus vj minus eij is the water values. Okay, now you calculate water values for non-allocating cells. You calculate the water values for the non-allocating cell and write it here in this bracket. Water values of non-allocating cell and write it here. So this ui plus vj minus eij is a minus 3. Correct na? Water value, the way I calculate the water value. Now here 2 plus minus 3 is minus 1, minus 1 minus 4 is minus 5. I am applying this formula. Formula doesn't change. Formula doesn't change. 2 plus minus 3 minus 8 is minus 9. 3 plus 3 0, minus 6 is minus 6. 4 plus 2 6, minus 7 is minus 1. 2 plus 2 4, minus 6 is minus 2. So these are the water values of non-occupying cells. Water values of non-occupying cells. Now, what is my conclusions? Conclusions. What are my conclusions? So conclusion number 1, if all the values of non-occupying cell are negative, all the values of non-occupying cell are negative, it means it is an optimum matrix. If all the values of non-occupying cell are negative, it means it's an optimum matrix. So I can see here that all the non-occupying cell are having negative, so it's an optimum matrix. Point number 2, if the water values of all the non-occupying cell are non-positive, means negative or 0. Suppose if one value is 0, it means there are alternate solutions. If one value is 0, non-occupying water value is 0, it means there are alternate solution. But if it is a positive, it means it is not an optimum matrix. Not optimum matrix. It means it is not an optimum matrix, and further iterations are required to find out the optimum value. So that's how we will find out that whatever initial basic feasible solution that you have calculated, whether it is an optimum or not. Correct? So it was a very, very important discussion. It was a very, very important discussion. So with the help of some problem, common problem, we try to find out the basics. Okay, na? Find out the basics. Let us see the next problem. Let us see the next problem. ABC, D, E, F, G, H. Transportation costs are and the problem is a balanced one. 200, 125, 225, 75, 105, 130, 155, and 85. Problem is a balanced one. Problem is a balanced one. 300, 400, 550. So this is also 550. Just check it once. Problem is a balanced one. Alright. So I will be little slow because I told you the one shot also you have to keep the pen and paper with you. So I'm doing little slow. You should also calculate by using penalty counter method the initial basic feasible solution. Okay. Penalties of row and column. Penalties of row and column. So because in one shot series also you should practice. If you do not practice, you will not get confidence. So I will be a little slow while solving this. You do on your own. 35 and 50, 15 penalty. 45 and then 55. And it's a 40 and next is 45, 5. Penalties of the column 45 and 55. 45 and 70. 25. 65 and 75. 60, 60, 0. Okay. So now select this one. Minimum transportation cost is 45. Allocate as much as you can. So cancelled. Calculate the penalties again. 5, none, 5, 0, 0. Penalties of row 15, there is no change. Then 5, and this is 40 and 60, 20. Correct? Because this penalty will not, this transportation cost will not be counted. Now select 20. And the minimum transportation cost is 40 here. Allocate maximum you can. So row is still 120 are left, but column can accommodate only 85. Okay. So that is also cancelled. Okay. Of course it was 5. It was 5. Okay. So 85 I have allocated. Again calculate the penalties. In the book I have already solved this, so I am just taking some reference so that I am not doing any mistakes live. So 45 and 50 is 5. No penalty. 5, 0, no penalty here. Now here minimum is 50. Next higher is 60, 10. Here because this column we will not count now. 45. The next is 65, so 20. and here the minimum is 60. Next higher is 75, so it is a 15. Maximum is 20, and the minimum transportation cost is 45. Column can accommodate 75 and the row 125. So allocate 75 here. This is also cancelled. This is also cancelled now. Okay. So now next, no penalty here, no penalty here. 65 and then 70. Actually 65 and the 77. We have 5. 5, 0, no penalty. Now what will be the penalties here? Because only 2 columns are left now. 5, 5 and the 5. So all the highest penalties are 5. You can choose anyone in this one. Whatever is the minimum transportation cost, 65. Allocate as much as you can, 130. So now only 1 column is left. So 1 column or 1 row is left. We don't calculate penalties. So 130, 70 is left out. 70 allocate here. Now in this row, out of 125, 75 allocated, remaining 50. So 50 allocate here. 70 plus 50, 120. 155 minus 120 comes out with 35, na? So this should also balance. Correct? So these are the allocations based on initial basic feasible solution. These are the allocations based on initial basic feasible solution. Initial basic feasible solution. Okay. Initial basic feasible solution. All right. So do one thing. Calculate the water values. I am making the same table again in the next page. Calculate the water values. So first of all, I'm writing the transportation cost. 50, 45, 80, 82, 70, 45, 75, 70, 65, 60, 65, 60, 35, 50, and 40. Now, what are the allocations? allocations 130 and 70. 16, okay. 50 and 35. 85. I'm just writing the allocations. 105. 75. I hope allocations are done. 75, 105 in the second row, 130 in the third row. All three rows are full, and the last one is, yeah. These are the initial basic feasible solution by using Vogel's approximation method. You can find out the total transportation cost also. Total transportation cost, it is a 45 into 75 plus 105 into 45 plus 130 into 65 plus 60 into 70 plus 65 into 50 plus 60 into 35 plus 85 into 40. 29,500. Is the total transportation cost. Is the total transportation cost. So now let us find out UI and VJ. Let us put 0 here. Water values are UI plus VJ minus CIJ. So this must be 60. This must be 65. Okay, na? If this is 60, this must be 5. If this is 5, this must be 40. This is 60, this must be 0. This is 0, this must be 40. This is 0, this must be 45. See, all UI and VJ came. Now what I'm interested to find out the water values of the non-occupying cell. Do it as I'm giving you pause for some time. Calculate the water values of non-occupying cell. Calculate the water values of non-occupying cells. Zero plus 40 minus 80 is minus 40. 65 minus 75 is minus 10. 45 minus 50 is minus 5. 70 minus 0. Minus 20. Minus 10. 45 minus 82, 50 is minus 37. And then 40 minus 35 is 5. So because the water value of non-occupying cell is positive, so it is not an optimum solution. Now what we have to do, because in the one-shot series, I am discussing only the variety. In the one-shot series, I am discussing only variety. So now, if there are positive water values for the non-occupying cells, select the cell having highest positive water value. This is the cell. Select the cell having the highest positive water value. This cell is called entering cell. Entering cell. Select the cell having the highest positive water value, and that cell is called entering cell. Now here you have to be a bit careful. You have to be bit careful. You have to be bit careful. In transportation, this is the only place where you have to use your mind. This is the only place where you have to use mind. Otherwise, it's a mindless exercise. From the entering cell, only a unique loop will be formed. Unique loop. A loop can be like this. Loop can be like this. Loop can be like this also. Loop can be formed by joining only the horizontal and the vertical lines. By joining only the horizontal and the vertical lines. By joining only the horizontal and vertical lines. And only the unique loop can be formed. You cannot draw the multiple loops. Loop should be that except the entering cell, except the entering cell, there will be allocations at each and every corner. Except the entering cell, there are allocations at each and every corner. You can draw only one loop. You cannot draw two loops. If two loops you are able to draw, it means there is some problem in the matrix. Only a unique loop you can draw. Some of you may be thinking, how we will write program for that? Because I told you, at the MTech level, all these things you will write programs when you are going to IIT Delhi is a very good place for industrial engineering. So how to write program? Teacher will help you, and you will have other intelligent people. They will help you to write programs. So there are allocations only at each and every corner. So see, this is the loop. I formed loop. See, allocation, allocation, allocation. At each and every corner there are allocation except the one we are entering. From wherever the loop start, you say positive sign. Let us say positive sign. Wherever the loop start, positive sign. Then alternatively put positive, negative, means negative, positive, negative, positive, negative. So loop, na? So alternatively, you can have positive or negative sign. So positive, negative, positive, negative. You try you will not get another loop here. You try, you will not get another loop here. You try, suppose I'm waiting 30 seconds. You try, you will not get another loop. Try. This is the benefit of live classes. Okay, na? Live classes, we can have multiple discussion. We can see the chat in front of me, and how the students basically do. It's a really dynamic mahal. You will not get another loop. Now, what you should do, select the minimum value. Select the minimum value wherever there is a negative sign. So minimum of negative sign here 70 appears. 85. So if there are multiple negative signs, 3. So 3 values we have to select the negative minimum value. Wherever there is a negative sign, there will be some values, na? Select the minimum out of it. Minimum is 70. So now what you should do, this 70 add at places wherever there is a positive sign. Here and here you add wherever there is a positive sign, and you subtract wherever there is a negative sign. Subtract wherever there is a negative sign. Select the minimum value. This minimum value you add at the cell wherever there is a positive sign, and you subtract from the cells wherever there is a negative sign, and prepare a new table. Prepare a new table. I told you, right? This is the only place where you have to apply your mind. First of all, my old matrix. First of all, my old matrix. If you solve, actually, if you know all the fundamentals, transportation will be very, very easy and quick. So now, $70 I will add here and subtract from here. So this cell will be non-occupying cell. So there will not be any change in 130. And here the 70 will come. No change here. A non-occupying 70 will come here. Second row, it's a 50. $75, $50. So there is no change in the second row. Third row, this is 105. $35 plus 70 is 105. 85 minus 70 is 15. Correct? So this is, oh, first of all, we have to see the degeneracy also. See here? M plus n minus 1 is equals to 3 plus 5 minus 1, 7. Allocations are 1, 2, 3, 4, 5, 6, 7. So no degeneracy. After each Modi method iteration, we have to calculate the water values again. Do it quickly. I believe a little slow. Do it quickly. I'm doing because now I already taught you this thing. So you can choose any number, water values will come out to be same. You can choose any number, water values will come out to be same. You can choose any number. And now water values of non-occupying cell. 35 minus 50 is minus 15. 40 minus is minus 42. 60 minus 5 is 55. Minus 5. 45 minus 5. 65 minus 5. 50 minus 20. Minus 40. Minus 15. So now all the water values are negative. All water values are negative. So it's an optimum matrix. This Modi method, we will keep on doing the iteration. Till all the water values of non-occupying cell comes out to be negative. We'll keep on doing. If it is 0, means it's an optimum one. But there are alternate solutions. Optimum one, but there are alternate solutions. Okay. So what is the total transportation cost? Total transportation cost. This into this, into this, into this, into this, into this, into this. So if you do that, answer will come about 29,075. These many rupees. Previously it was 29,500. After Modi method, 29,075. So there is an improvement in the result. There is an improvement in the result. Okay. There is an improvement in the result. Okay, na? Everybody is okay? Modified distribution method, or we call it Modi method. Let us see another question. Another question? A, B, C. 1, 2, 3, 4, 5. And the transportation costs are given to you. Or capacities. And the transportation cost and the capacities are given to you in the table. 4, 5, 6. 2, 4, 5. And the capacities are 4, 4, 6, 8, 8. And the row capacity is 8, 12, and 14. So now first of all we have to see that whether transportation column is balanced. 8 plus 12 is 20, 34. And what is the column capacity? 4 plus 4 plus 6 plus 8 plus 8? 30. So in this problem what I am able to see, that my matrix is not balanced one. Matrix is not balanced one. Before going for Vogel's approximation method, my table should be a balanced one. So to make it balanced, what we do? Because column is falling 4 short, so I will add a dummy column, and the dummy column will have 0 transportation cost. I will use dummy rows and dummy columns. I will use dummy rows and dummy columns to make the transportation matrix balanced one. I will use dummy rows and dummy columns to make the transportation matrix a balanced one. Before I go for initial basic feasible solution, my transportation matrix should be a balanced one. So capacity 4 and transportation cost 0. So in place of 30, now it's 34. Now it's a balanced one. By adding dummy column, now my transportation matrix is a balanced one. So can you, I will be a little slow here. I will be a little slow so that all of you can catch up. Now calculate penalties. Penalties. Now in the calculation of penalties, this we will treat as a regular cell. So minimum transportation cost to 0, next higher is to 1, 0, next higher is 3. Here the penalty is 4 and 5, 1, 2, 3 and 4, 1, 0, 2 to 0, 1 and 3, 2. So maximum is 3. In that row, minimum transportation cost is 0. Allocate as much as you can. So 4 allocate you. Okay. We will treat this as a regular cell. Dummy cell, we will treat it as a regular cell while calculating the penalties. So 1, 2, 1, 0, 2, no penalty. But the penalties will change here. 2, 2 is 0. Correct na? 1 and 2, 1. 3 and 4 is 1. So highest penalty goes for this one. Minimum transportation cost is 2. Allocate as much as you can. Here is the 4, that is 12. 4. This is gone. Again calculate the penalties. One, no penalty. 1, 0. No, I think 3. It's not 0. 1 and 3. It will be 2 here actually. This penalty is 2. So 2, 2. Now this row and this row, I will select that column where there is a minimum transportation cost. So minimum transportation cost is here. I will allocate 8 because the row capacity is 12. So this is gone. I'm going by the procedure. Even the solution will not change. Penalty is 1, 2, 1, 0, no penalty, no penalty. Now here penalties will be 0, 2, 2, 2, 4, 2, and here 4 and 5, 1. Select this penalty. Minimum transportation cost is 2. Allocate as much as you can. So 8 column capacity, but left out is only 4. Left out is only 4. Now again calculate penalties. 4, 6, 2, 2, 5, 3, 3, 4, 1, 2, 7 is 5. No penalty, no penalty. And here whatever is left out, 2 to 0. No penalty here. Then here 4 and 5, 1. So maximum penalty is 5. Minimum is 2. 4 is already allocated, 4 left out. This is gone. Correct? Calculate the penalties again. Here 2, here 3, 1, no penalty, no penalty, no penalty. And here first 3 columns are gone. So this is 1, 2, 3, no penalty here. And here is 1. So maximum penalty because belongs to the second column. Minimum is 2. Column capacity 4, row capacity is 4. So by allocating this 4, both column and row are satisfied. Here there is an important point. Here there is a very, very important point. While allocating during the initial basic feasible solution using Vocal's approximation method, by allocating, if it so happens, see very, very carefully what I am telling you. While allocating, if it so happens that both row and columns are satisfied simultaneously, both column and rows are satisfied simultaneously, it means that degeneracy is introduced into the system. When both row and columns are satisfied simultaneously, it means degeneracy is introduced into the system. And how to handle degeneracy, I will talk to you later, okay na? Degeneracy is introduced into the system because both columns and rows are satisfied. So now only one row is left. You just allocate the way it is. This is the 4. How much here left out? 6. That's it. 4 plus 6, 14. 8 plus 4, 12. 8. Okay. Now make the table again. Make the table again. A, B, C. I am not discussing too many repeat questions. I am discussing only variety. One, 2, 3, 4, 5, and this is a dummy. It's a dummy. Four, 5, 6. 2, 4, 5. 3, 5, 4. 2, 2, 7. 6, 1, 3. And dummy, of course, 0, 0, 0. And what are the allocations we have got? 4 and 4. 4, 4. Okay. 4, 8. 4, 8. 4, 6, 4. These are the allocations. Okay, these are the allocations. What I told you while allocating the cells, what I told you, while allocating any cell, when both rows and columns are satisfied simultaneously, it means degeneracy introduced into the system. Now, what is m plus n minus 1? M is 3, n is 1, 2, 3, 4, 5, 6. Totally 8, na? Dummy column will be treated as a proper column. Dummy column will be treated as a proper column. Now, next 3-4 minutes, there are some very, very important points I am going to tell you. You have to hear very carefully. I am going to tell you very, very important points. In the next 2-3 minutes, you have to hear very, very carefully. Number of allocations are 1, 2, 3, 4, 5, 6, 7. Number of allocations are 7. 7 is less than 8, na? So system is degenerated. System is degenerated. If the system is degenerated, I cannot apply the Modi method. If the system is degenerated, I cannot apply the Modi method. Stepping stone I am not discussing here. I will discuss only the Modi method. Because in the one-shot series, our target of our team Dhrona is to benefit you maximum by consuming your minimum time. Benefit with you maximum by consuming your minimum time. That is our target. So, to remove degeneracy, now here very, very carefully, to remove degeneracy, I allocate one insignificant number epsilon. I hope everybody is hearing very, very carefully. To remove degeneracy, I will allocate one insignificant number epsilon to a non-occupying cell. To a non-occupying cell having minimum transportation cost. To a non-occupying cell having minimum transportation cost. Having minimum transportation cost. Now, you know, different works, there are different arguments. I will tell you the conclusion. This epsilon, we will not allocate in dummy cells. We will allocate in the main matrix. That is the point number 1. This epsilon we will not allocate in the dummy cells. We will allocate in the main matrix. That is 1. If you follow this procedure, number of iterations will be less. That's the point. Number of iterations will be less. Because till your water values comes out to be negative, we have to keep on doing the iterations. So the epsilon you allocate in the main matrix, not in the dummy. Point number 2, while allocating epsilon, loop should not form. Loop should not form. Loop should not form. Okay? Loop should not form. Like that type of loop. Either this, or like this. Any type of loop should not form. So now let us remove the degeneracy first. I will not allocate epsilon here. What is the minimum transportation cost here? 3. Allocate epsilon here. So loop is not forming, na? See, no allocation here. No loop is being formed. Okay, na? No loop is being formed, so 3 you can allocate here, no problem. At location 3. Now degeneracy is gone by allocation. There is one more point here I would like to tell you. Suppose this number is 6. Suppose this number is 6. I will allocate epsilon 1 and epsilon 2. Two numbers I will allocate, epsilon 1 and epsilon 2. Criteria same. Loop should not form. If the loop forms, I will go to the next higher transportation cost. If loop forms, I have to go to the next higher transportation cost to allocate epsilon. Correct? Correct, na? Now calculate the water values. UI Vj. Let us this as 0, 6, minus 6, minus 2. So all UI and Vj's we have got it. So now calculate water values of the non-occupying cell. Water values of non-occupying cell. 6 minus 2, 4 is minus 1. 4 minus 7 is minus 3. 4 minus 5 is minus 1. 2 minus 4 is minus 2. 2 minus 5 is minus 3. Minus 2. Minus 2, correct, na? 1 minus 6 is minus 5. 2 minus 3 is minus 1. 0 plus 4 is 0. Correct? So in the matrix we can see, that no value is positive. In the matrix we can see that no value is positive, so it's an optimum matrix. But what I can see, for a non-occupying cell, water value is 0. For a non-occupying cell, water value is 0. It means there are alternate solutions. It means there are alternate solutions. It means there are alternate solution. And how to find out the alternate solution? Again, same loop. It will start from here, and at the boundaries there are allocations. So loop will be like this, see, plus, minus, plus, minus, plus, minus. So I will select the minimum of 4, 8, 4. Is a 4. So wherever there is a positive, you add 4, and wherever there is a negative, you subtract 4. So by that you will get alternate solution. After finding out the alternate solution, do not calculate the water values again, because that is an already optimum solution. Na? After finding out the alternate solution, do not calculate the water values. Alternate solution, that's how to find out. Okay, na? So in this transportation, what I try to do basically, in the transportation, I have taken some selected problems, and based on that, we try to learn some key features of transportation. In GATE also transportation problem comes. Very, very beautiful problem. See the P by Qs. So this one-shot series of transportation, this lecture I finish at here. Next lecture will be sequencing. So be connected. Thank you very much.